Hey there everybody, this is Jonathan from Star EV Tech Support, and I'm driving over to our test drive route in the spot that we used last time in our video where we showed you how to use the Bluetooth app to check the current draw from the battery. This time I'm going to show you how to use an infrared thermometer to check for any brake drag. You can also have an issue where there's mechanical drag in the wheel bearings, and I'll go ahead and use the thermometer to show you that too, how to check for it anyways. So in a second I'll be over at the test drive route and I'll show you how to use the temp gun. What I'm going to do is use an infrared thermometer such as this, and I'll show you where I'm going to point it so that I can get a good reading of the temperature of the wheel. So in here you see how the laser pointer has a little dot. So my temperature reading is being pulled a little bit below that, so let's just estimate an inch below that. So right here it says 91.2 on our thermometer. If I check the other one, I have 89.2. So that's not very much difference. If I come to this wheel, I'm going to shoot the laser in between the wheel, and I'm going to count. I don't want to put my laser right here on the wheel. I want to raise it far enough out so that my 1 inch space is accounted for. So right here, if I'm reading this, it's 99 degrees. Coming to this side, right here, it's ranging anywhere from 136 to 127. So if I use that temperature, they're not really that far apart. Now, one thing that you need to bear in mind is the ambient temperature outside. Right now it's about 90 degrees outdoors. So you're starting from that ambient temperature outdoors and going up from there when you're testing the brakes. If the brakes are very far apart, usually they're going to be very far apart in temperature in the rear. So if your rear wheels are differing in temperature by, let's say, more than 50 degrees, you know that one wheel is dragging. That's where you're going to go and start checking your brake cables and the equalizer, the piece that kind of balances the two cables to each other. What we found with that equalizer is that one side can be kind of cocked to one side, basically putting more pressure or more tension on one cable than the other. Anytime you have that happen, the results are going to be visible in the temperature. In that wheel, you would begin by backing all of the adjustment off on the adjuster. Then you would go to the equalizer and make sure that it's pretty even side to side, not, tilted to one side as opposed to the other. Once it is evened up, then you can go back to the wheel and adjust both sides so that you have no drag on the drum. Now, what we have found also is that when you press the brake once or twice, that the brake shoes will shift towards the front. If that happens, you're going to need to lubricate the white piece of Teflon or plastic up at the top of the backing plate. That piece is supposed to be able to slide back and forth, allowing the brake drum and the brake shoes to center themselves. Usually what happens is, when there's no lubrication on there, the shoes will cock to the front and it will not be centered in the drum. It'll always be riding on the front. So you want to use a lithium type lubricant. Usually we use the one in a spray can to lubricate behind that white Teflon and also in front of where the two pivot bolts are. That is going to allow the brake drum and shoe assembly to kind of recenter itself instead of just riding always on the front. Right here we are showing 118, and on this one we have 128. Going to the back, we're going to repeat the same process we did before. Here we have 109. Proceeding to the other side, we have 101. So the differences that you're going to find between the short car and the long car are, if you have a brake drag with the long car, this one here, a 4+2, you would adjust the push rod going into the master cylinder. That push rod may be preloading the front brakes as opposed to the rear brakes prematurely, so that the front brake is staying a little bit applied. If that's the case, you would adjust that push rod going into the master cylinder and then retest. If the brakes are heating up right to left in the rear, then you would go the same route as before, where you would adjust the equalizer and make sure that the tension is even side to side on the brake cables. Now you may be asking, what's the importance of the brake drag at all? And in our last video where we showed the amp draw on the lithium battery, I mentioned that brake drag will deplete the battery faster. So as an example, let's say you have your phone battery, your smartphone battery, and you're running one app. That may deplete your battery at a certain rate. Now, let's say you have many apps open, and some of them are using GPS, and one's using Bluetooth, and one's using Wi-Fi. All of these apps are going to deplete the battery faster. It's similar with the lithium battery that's in the cart. If you are pulling against that resistance that's in the brakes, that resistance is going to wear the battery down faster. This is why we want as little brake drag as possible. Temperature is our way of checking to see what that brake drag is or where it is in the vehicle. So this is why it's very important to make sure that your brakes are not dragging, your tire pressure is properly adjusted, and that you don't have anything that you're pulling against, adding to the output needed from the battery. So hopefully this video can help you to see how you use one of these, how you use it to pinpoint where the trouble spot might be, and now you know some steps in order to take to fix a brake drag problem.